Alright, good evening. Okay, so today we move on to the next concept, okay, of trigonometry. Alright, now before we actually move on to the actual chapter, trigonometric function, okay, let's recap on what we have seen prior to this, okay, a lot earlier. Okay, so we started off with, we have seen this before, the concept of quadrants, okay, the quadrants. It comes from a unit circle. Okay, as you know, quadrants, you've got 4 quadrants. Quadrant 1, Quadrant 2, Quadrant 3, and Quadrant 4. Okay, now if you notice previously, all our angles are actually positive angles, meaning when we actually measure the angles, we're actually going in this motion. It's in an anti-clock, okay, anti-clockwise motion. 0, 90 degrees, 180, this is 270 and 360 degrees. Okay, so this is called the first quadrant, second quadrant, third and fourth quadrant. Okay, now as we have seen, these angles marked here, these are called reference or corresponding angles. Okay, they actually represent acute angles in each quadrant. All right. And another thing that we looked at is, as we know, we have got 3 functions. If you're talking about trigonometry, you've got sine, cos, and tangent. Okay, so in the first quadrant, all my 3 functions are positive. So we use all, okay, sine, cosine, and tangent. They are all 3 positive. In the second quadrant, only sine is positive. Okay, in the third quadrant, only tangent is positive, and in the fourth quadrant, only cosine is positive. Alright, so these are the functions situated in our 4 different quadrants. Okay, alright. Okay, so that's the first thing we saw. Okay, the second thing is this concept of graph of trigonometry. Okay, this is the shape of the graph. You should know because it will actually help you in problem solving later on. So the first one is called the sine graph. The sine graph, this is how it looks like. Okay, it starts from 0. Okay, this is your amplitude or the peak, which gives you the value of 1. At 180, it is 0. 270 is negative 1. And 360, it comes back to 0. Okay, so this is the graph of sine. Okay, next you've got the graph of cosine. Okay, the graph of cosine is like a valley. It's a valley. So it starts from 1, comes down. This is 0, negative 1, 0, and back to 1. Okay, so if you notice, the amplitude for both these graphs is actually 1. Okay, this is also a 1. So this is for the graph of sine, the graph of cosine. Okay, then you also have the graph of tangent, the tangent graph. Okay, so for tangent, starts at 0 at 90 degrees. This is an asymptote, so there's no value at 90 degrees. Okay, 180 degrees, the graph actually reaches 0. So these are both ends, which are actually amplitudes. And at 360 degrees, it is 0 again. Okay, so this is the graph of tangent. Okay, and this is something that you have seen before. Okay, so these are the functions of trigonometry. Okay, so now in this chapter, we have always seen 3, the sine, the cos, and the tangent. So sine is the opposite side over the hypotenuse, cosine is the adjacent side over the hypotenuse, and tangent is opposite side. Okay, alright, so now we've got an extra 3, which is the cosecant. Cosecant tangent is defined as 1 over sine. Secant, Okay, sorry, cosecant theta, this is 1 over sine theta. Secant theta is 1 over cos theta. And cotangent theta is actually 1 over tangent theta. So previously we have seen 3, sine, cos, tangent. So now we add on cosecant, secant, and cotangent. Alright? Okay, so these are the 6 functions of trigonometry. Okay, now we move on to the next part. Okay, this is also something that we have seen before, something called special angles. Okay, now we have got 3 special angles. One is 30, 60, and 45 degrees. Alright, they all originate from one equilateral triangle. This equilateral triangle. Okay, so every side is 60. So when you actually split this into half, this is the height of the triangle. So each angle becomes 30. So if this is 2, denoted by 2 units, so this will be 1 and 1 because they are actually, okay, the same length. So 2 here, 1 here, using the Pythagoras rule, this becomes square root of 3. So, and this is 30 degrees, this is 60, and this is a right angle. So now by using this right angle triangle, we are actually able to determine the angles of 3 functions, which is sine. So sine 30 is here. So sine will be, according to our formula here, your sine is actually the opposite over the hypotenuse. Okay, so what we have seen earlier. So your sine becomes opposite over hypotenuse. So this is my opposite for 30, so it's 1 over 2. Okay, cosine 30 is adjacent over hypotenuse, which is square root of 3 over 2. And tangent 30 is opposite over adjacent, so it's 1 over square root of 3. Okay, now likewise for 60, sine 60, opposite over hypotenuse, square root of 3 over 2. Cos of 60, adjacent over hypotenuse, 1 over 2. And tangent 60, opposite over adjacent, square root of 3 over 1. So it becomes square root of 3. Okay, now for this 45 degrees, which is also considered a special angle, we actually use isosceles triangle. So this is 45, this is 45. This is an isosceles right angle triangle. 45 degrees for both. This is 90 degrees. So my length is in ratio of 1 to 1. So using Pythagoras rule, this becomes square root of 2. 1 squared plus 1 squared, square root of 2. So if you want sine 45 degrees, sine is opposite over hypotenuse, 1 over square root of 2. Cosine 45, adjacent over hypotenuse, 1 over square root of 2 again. And tangent 45 is actually 1, opposite over adjacent. Alright? Okay, so this is considered special angles. Thank you.